So, our next speaker, amazing Jyoti Yadav. Now for a critical topic in today's digital world. So please welcome our next speaker. And Jyoti will take us on a deep dive into agentic cyber defense with external threat intelligence. It's something I understand crucial and important. So, waiting for your such amazing talk.
Thank you, Anna. Thank you for the introduction. I will start by introducing myself. Hi, everyone. I'm working as a security data scientist at Microsoft as of now, and I have somewhere around 7 to 8 years of experience in data science field. I've worked with crypto industries, banks, and other industries evolving around the cyber stuff as well. Before we deep dive into this entire session, I would like to make this disclaimer that whatever tools that I'm suggesting are like my own suggestions. It has nothing to do with the with Microsoft. So yeah, let's just deep dive into it. I'll talk about a bit about like what was the motivation behind it, why the agentic system is required, and what are we trying to achieve out of the entire presentation, or how we use agentic AI there. Um, as you have seen, like cybersecurity is a very tedious space. There is a lot of technical knowledge which is required at the back end to understand even a simple things like IP addresses or maybe the domain, and the background data which is fetched. So it becomes an essential part to introduce like intelligence into the system so that it can help you understand even the smallest bits of the data that will be receiving. And it is also like very helpful in understanding what is happening in the behind the scene, or if you want to change anything which is related to the cybersecurity data, or if you want to understand a very specific point specifically as well. So in this particular demo, we are gonna see how a conversational agent can be created based on the external threat intelligence, and I'll be taking the example of a domain or IP addresses there. So majority of the times, what happens is like we receive some sort of an email that contains certain link or certain domain attached to it, and since on our day-to-day job we might skip the part where we try to see what the email is all about and try to see if it is phishing or not. So this engine provides you like a better solution corresponding to it. It If you enter like kind of a domain or an IP address into the system, it'll tell you like what are the likelihood that this particular IP or domain is actually malicious. Yeah. um there are like thousands of new domains that are created like every day, and their majority of them are like phishing, and they are created like temporarily for these malware campaigns or these purpose specifically. Now what happens is like if you try to create a static rule based system where you say that if the domain was created or the IP address was generated like before 100 days before or is very new, then you provide like kind of a suspicious act associated with it. But there's a kind of a limitation related to it in a way that if there is a context or what is happening on the IP address or the domain, or you try to fetch the content, the static rule might not be able to fulfill the scenario where you want to understand what is there on the website itself. Also there are like kind of high false positive and rates that require like expert intervention, and we would want that these rules that we are making or the system that we are building is taking consideration into the false positives or the user feedback as well, and keeps on taking that user feedback to train itself to make the entire system more and more useful and app per users. Now the question arises like why agentic AI is something that we want. So in the previous session, we already discussed like what agentic AI is. They have like autonomous decision making power. So if we have like multi-stage investigation at hand, then it becomes like an essential part that we use that step and use like kind of a organization or orchestrator agent which decides like what we want to do or what part of the tool, or what next step actually should be taken. So it will be like, instead of us deciding on certain rules or static rules, it will be the agent deciding on that. um, le- uh, Apart from that, these LLMs have like capability of using different signals and doing coherent analysis corresponding to it, and providing a result based on the observations that he has been observing. Yeah, these LLMs are actually can be leveraged to get the diverse signals as well. We'll talk like a bit about like what the architecture looks like before deep diving into each and every component, and then going ahead with the demo as well. So to start with, just the user can interact, and or to provide like a good user experience, I have built like a Streamlit app where the user can actually query. The query actually goes to the head agent that is based or built out of LangChain, and that agent decides like what further steps are supposed to be taken in order to fulfill the requirements of the query that user has actually posted on the app. Now, orchestrator is agent tries to see if the user is asking about a very particular domain or IP address, what tools are there at its dispense and it can use. So it has, as of now, for the demo purpose, like fetch, who is like one of the data sources that provides you information about IP address and domain. GeoIP lookup, it provides information, geographical information corresponding to a very particular IP address. Thread feeds is coming from VirusTotal, and it provides you like how many malicious hits or unrest hit are actually observed on that particular domain. Then the score target is like one of the deterministic factor that takes into consideration all these above data and tries to create a deterministic score out of it, depending upon like pre-static rules. And compose explanation is like kind of using LLM, which takes the score, like the deterministic factor, as well as like other factors also into consideration, like the raw data that we are fetching out of it, in order to understand what exactly, or if it is worth classifying this particular domain or IP address as malicious. Now, whatever data we are able to fetch out of it, we are storing it into memory DB, so that the agent can actually again look up into like last queried data and go ahead and see if it needs to do like all this analysis of or if the user has like some other information required from the last or previous data itself. Once the output is provided to the Streamlit app or to the user, it is required to or asked for a feedback, and this is the DB that stores like every other feedback that has been received based on the observations that you see in the memory DB itself. Now, the feedback and the memory DB is something that is accessible to the agent itself to make the decision and improve the prompt over time. And for the final kind of justification, or if you want to monitor your agent, how it is performing, at what stage it is getting the error, so we use Prometheus metrics, and you can log it into Grafana and create alerting out of it as well. Now let's deep dive into like each and every component to understand what they are actually about. First of the component is like the data collection tool. First of the source is who is data source. It has like a local DB that you can download, as well as there is like API also available corresponding to it. You can fetch the data on demand basis as well. This is like one of the example screenshot from one of the dummy data that I use. So as you can see, it provides you or gives you access to the IP address that corresponds to this particular domain. Then it gives you like what is the registrar, what is the who is server, referral URLs, what are the dates when this particular domain was actually created, when was it last updated, and when it actually expires. There are like other information as well corresponding to it. So as you can see, like this much information itself is quite difficult to understand if you do not work in the cybersecurity space or you do not have like expertise into that domain. So if we use like LLM and provide this particular data, LLM will be able to tell us like certain information which might take a lot of time to understand and maybe miss majority of the time. Second data source is GeoIP. Again, it has like the local DB and the API on calls as well. This is like one of the very example of what it gives as kind of output. So it gives output in JSON format, and it shows us like this what is the country code where this particular IP address is or the domain belongs to, what is the region name, the city specific as well, the zip code, latitude, longitude, and the time zone as well corresponding to it. So this kind of information might be useful at certain scenarios if you want to filter out certain locations or geographies as well. Next data source is VS this is like another snapshot of what particular thing looks like. So it gives like community score out of 94. It has registrar information as well, creation date as well, and the last analytics date from the virus total that they performed it on. Now, as you can see, the crowdsource context, like the low, that this example.com is not, doesn't seem to be malicious just because the confidence is kind of quite low over there. Um, there are certain, yeah, threat actor under radar mysterious, which is like backdoor, and this provides like more information on certain indicators associated with this domain. So these kind of things like takes a lot of time to understand, and even for me, it is I have to go through each and every detection and then classification corresponding to it, and then see what is happening. Now, let's move to the other section of this particular domain. So, we are at the stage where we want to decide like whether a particular um, uh, domain is malicious or not. We have like deterministic features as well as some certain flexible features as well. Deterministic feature, as I previously described, was one of the tools, and it creates or generates a score between 0 to 10 based on certain structured data that is actually enriched through the previous data tools that we were discussing. So the part of this component of the score is domain age. Another one is the country. Then last one is the threat heads. Flexible feature is we are relying on LLM's knowledge and try to see if they are able to find anything which is beyond these particular deterministic feature as well. So it has like text data which is finally added to the LLM, and it actually end up getting the verdict as well. Now LLM doesn't only get the flexible feature or the text data, it also gets the score as well, so that it can make decision based on like previous judgment that we had related to this particular domain. Uh, just for the purpose that we want it to be continuously learning, I have created like two more tools, which are memory tool. So memory tool will help you answer question, what was the last domains I checked? How does that this domain compare to the last domain I checked? And there is like feedback integration tool as well that auto ingest the feedback from the user into the prompt itself and improve the answers from the LLM over time. Now let's go ahead and have a look at the demo also. So this is like I'm using VS Code for this particular for the interaction purposes. I have like all my like files created over here, and since I'm hosting it on Streamlit, I start by running the app itself. And as you can see it over here. Now over here you can ask a very specific question as well, and you can provide a domain or IP address straight away too. So let's say I want to ask, tell me what all you know about example.com. The query has been sent to the engine and it is running as of now, and we should have some answer pretty soon. Yeah. So as you can see, it fetched like information from various data sources, and it is showing you like what is the domain name, what is the date created, then what is the registrar, geolocation as well, how many malicious hits have been there, undetected, harmless, and a composed risk score, which is based out of the deterministic thing, and the explanation related to it as well. So the score difference that you see over here, it is like they generated by the deterministic framework, but this risk score is generated by the LLM itself. So it says that LLM thinks that even if we have like some sort of difference between these scores, LLM has this indication that it is a very low level of risk. And let's say you want to understand like certain IP addresses, or if you feel like that this particular domain that I entered over here is not malicious as per my understanding because of ABC factors, or it belongs to your internal company IPs or domains, so you need to actually kind of whitelist this particular domain. So you can provide this feedback over here. So you can say like this is right, or you can say this is wrong, or you can provide. So let's say I say that this is correct, and I provide a comment that this is company domain and white list. And this feedback has been incorporated into the LLM itself. And you can ask like further questions related to it. If you are not able to understand, let's say, harmless or undetected in threat feed, you can go ahead and ask this question as well, and then it will be able to answer that question too. Now let's see like how the model has been making a decision, or the agent has been making a decision behind the scenes. So this is what the output looks like. um, it shows like step by step process, like what particular tool that we were showing before has been invoked and in what kind of logic. So as you see that we entered example.com, it was able to fetch that domain out of the query itself. So that was like orchestrator uh, agent that did it. Now corresponding to it, it invoked fetch who is, and who is actually started giving like this kind of data corresponding to it. Once it is complete on that, then it started looking into geo IP lookup, and this is the output that it received out of the API call there. Similarly, for total fetch thread feed, it is again giving these kind of output that we are able to see over there as well. Now it tried to look at like what deterministic scores actually says. So it says like it is 1.7 based on certain rules, and then post that it used LLM with all this information to provide its judgment on the entire score. So as you can see the entire output which is generated out of this code as well. So this is what the demo, or how the agentic framework works at the back end, and you can see how intelligently it actually picked up. I provided only the example.com, and this geo IP works majorly on the IP address. So what it did is it actually picked up the IP address corresponding to example.com, and then input that into the geo IP lookup and able to find this output. So this is how smartly the agent actually work on, or is delegates or uses its tool to answer the query of the user as well. Now let's go back to the presentation itself. Yeah. Now once we like there are like a lot of information that goes around this entire building process and multi-agent systems. Now there are a few considerations that we might need to take care of or be aware about while you are building these things. Packaging options, we already have seen that Streamlit app do pretty good job in doing that. It has like minimal code changes and ideal for demos as well. And or you can use fast API services so that it is like production ready, or any other person can also call this API and use the service as well. Then CLI tools are another like lightweight scripting integration that can be done for these agentic AI models to be like more useful. Beyond this, since this particular use case can be actually expanded to other domains as well. So for example, not only looking at domains, let's say you want to look at thread feeds, or you want to see what is happening, or what information is available, or what CVs are available corresponding to a particular uh, maybe theme that you are interested into. So for example, ransomware. So you want to see what all CVs corresponding to it are in the market. So that is like kind of expansion which can happen, and a single tool may be able to um, uh, give you answer corresponding to it as well. For infrastructure purposes, you can make it serverless. You can make it Docker build uh, things as well. Then you can use Kubernetes. Like totally depends like how you want to see or productionize it in the process. CI/CD pipeline, GitHub can be used over there. And since whenever we try to look into these kind of applications, there is always a chance that once you try integrating a lot of other skills to it, or a lot of other tools to it, it becomes kind of messy. So for each and every integration that you do, it is a common practice to do automated testing. Maybe you can use Pydantic for that, or create like unit test for these particular tools when they are added or pushed for like further releases. In terms of scaling and observing like where's your particular models failing, or you are getting error out of it, or what is the latency corresponding to it, we can use Prometheus metrics as well. And it is very good way to understand how much error rate is, or what is the user experience at the end of the day. In terms of alerting, so for example, there are anomalies in a way that there are a lot of user queries coming, or and a lot of users are getting error out of it. It is a good way to actually look into it. Then logging and tracing. So it is like always a good exercise to see or structure or store your log somewhere, and then go back to it and understand how what the users are actually asking, how I can change the agentic AI, or improve the prompt, or add other functionality to answer their questions which are not being answered today. Let's talk about like the data privacy and governance corresponding to it as well. It is advisable that we do not store any kind of sensitive data in memory or feedback, or anything that we are actually do not want to share with like another user, because feedback and memory both are used for um, prompt optimization, or answering the question. Basically, they are accessible to LLM, and LLM can if it doesn't have like that kind of filter of not sharing personal identifiable information, it will actually end up sharing that information in the conversation somewhere. Then data retention policies, how old, or because the prompt has kind of a very limited token. So, and if you want to see or want to develop the model or prompt adjustment through feedback over time, it might be the case that it might overflow. So data retention policies might be like quite helpful from that angle as well, apart from looking into or reducing a timely it in timely manner, or removing the data after 6 months or something like that. Then there are like certain kind of encryption that you can actually use to make it like more secure at the end of the day. Next, corresponding to it is API key and secret management. So for OpenAI, for Whois, for VirusTotal, and all the calls that we are making through via API, they require API secret keys, and those keys are not supposed to be a part of your code itself. So it's better to use either store it in an environment variable when you are testing it locally, or store it in a key vault that can be used to fetch those secrets, and they are not logged anywhere. Now, monitoring for OpenAI, because I'm using OpenAI's API in order to create this entire framework. But whatever engine or whatever LLM that you are using, end up using behind it, try to optimize it based on like what kind of things it is actually good at. So, for example, GPT 3.5 Turbo is something that I'm using as of now, and it is primarily based out of like has the minimum um, uh, uh, cost associated with depending upon like 1 million token uh, uh, which it is actually generally measured in. So and generally what happens is like GPT-4 is like a costly model but is like good with tools as well. So let's say if you want to go ahead and use GPT-4 just for the tool selection, you can use that. And you can use GPT 3.5 for like other tasks for explainability, so that you have like you are not using blindly one version of the tool at every stage. uh, Towards the end, I would like to talk about like role-based access as well. So some of the API endpoints might not have access, or you do not want certain users to have access to like certain information as well. So for example, for a user who is new to the application, you want to um, uh, you know limit their access to the memory or the feedback DB. So you add like the access level infrastructure over there, so that the new users are only able to ask questions but not able to fetch the feedback itself. Logging every action is like another important thing to go ahead with, um, with timestamp of course, and the user who's making the query, so that you can always go back and see if there is an overflow even after applying the RBAC or not. Yeah, this was pretty much it from my end, and feel free to join me on LinkedIn. And if you want to talk about the entire project, or if you have like another idea you want to collaborate, I would love to go ahead and talk in that direction as well. Thank you.